Alright guys, so hello, welcome to this video tutorial for RC Hibbeler's Engineering Mechanics Statics textbook. So we have this problem from chapter 5 here, which is asking us to determine the horizontal and vertical components of reactions at the pin A and rocker B. I've replicated the diagram on the right hand side here. Let's go ahead and label up those reactions that the question is asking for. So first of all, we've got the reactions at A. I reckon let's just label them RA, Y and RA, X. And we've got this reaction at B. Let's just call it R subscript B. And we could kind of add the vertical and horizontal components to our diagram here. Let's just call them RB, Y and RB, X. So looking at this problem, and it's a similar case for a lot of problems like this, it's almost like we have three options. There's three different types of equilibria that we could concern ourselves with here. Vertical equilibrium, horizontal equilibrium, or moment equilibrium. Now, I'm kind of lending myself towards moment equilibrium to start off with, just because I noticed that if we were to take moments about B, then we could use that basically to solve for AY, right? Because there's only two moments being produced about B, the one produced by this 4 kilonewton force here and the one by the reaction at A. So let's go ahead and solve for that then. So we could say the sum of moments at B acting clockwise, doesn't matter, are equal to 0. Therefore, moments acting, or the sum of moments acting clockwise are equal to the sum of moments acting anti-clockwise. Let's go ahead and look at our clockwise moments then. So the clockwise moment, there'll only be one, and that's produced by the reaction at A. And we could describe that as 8 times RA, Y. And that's equal to the anti-clockwise moment produced by this 4 kilonewton force, which we could just describe as 8, 2 times 4, right? Okay, so by inspection, RA, Y is equal to 1, right? 8 divided by 8, that gives 1. Let's give it a unit as well, 1 kilonewton. Okay, so I mentioned earlier, three equilibria ideas: moment, vertical, horizontal. I reckon let's move on to doing vertical now, just because I noticed that in the vertical, we've got RA, Y, which we now know, it's 1. We've got 4 kilonewtons, and we've also got RB, Y. So let's go ahead and solve in the vertical. So the sum of the forces in the Y are equal to 0, or in other words, what's acting up is equal to what's acting down. What have we got acting up? Well, we've got, RB, Y, which we're solving for just now, plus RA, Y, which we know is 1. And this, and acting down, we've got this 4 kilonewton force here. So we could say, therefore, RB, Y is equal to 3, right, if we subtract 1 from both sides. Now, RB, Y, I would note that we're only looking for the reaction of the rocker at B. So we're looking for RB, right? If we wanted to express RB, Y in terms of RB, we could express that as RB cos 30, right? We note that we have a kind of 30-degree angle here. And if we kind of imagine ourselves taking this idea and just kind of rotating it 90 degrees anti-clockwise, then we can say that RB, Y is just RB cos 30, sorry. So we can say RB cos 30 is equal to 3. Therefore, RB is equal to 3 over cos 30 degrees, which I happen to know is equal to 2 root 3. So we can say 2 root 3 kilonewtons there. Okay, and then finally, let's go ahead and resolve in the horizontal. This will then enable us to solve for RA, X, right? So the sum of the forces in the X are equal to 0. In other words, what's acting to the left is equal to what's acting to the right. What have we got acting to the left? Well, we've got RB, X, which we could alternatively describe as RB sine 30. So let's do that. Well, noting that we've established RB is 2 root 3, let's just write 2 root 3 sine 30 for what's acting to the left. Well, what's happening to the right? Well, we've got RA comma X, so let's add that to our right-hand side. And we've got a nice neat equation here that you could just bung 2 root 3 sine 30 into calculator. And I happen to know that sine 30 is equal to a half, so we could say, therefore, RA comma X is equal to root 3 kilonewtons. And those are our solutions. So if you have any questions or comments about that problem, please feel free to leave them down in the comment section down below. Otherwise, thank you very much for watching.